Okay, so last chapter we did a lot of exponent rules. Do you remember what the rule is? If you are multiplying like bases, what do you do to the exponents? Remember, if we were multiplying, then we add. What happens if we were doing power?
Multiply.
So we would have x to the 2 times 5, which is x to the 10th. What happens if we were dividing?
Subtraction.
So we do x to the 2 minus 5, which is x to the negative 3, and then that ends up reciprocating 1 over x to the 3. Right? But the main things that we need to remember is the operations that we do on the exponents compared to the operations on the bases. If we are dividing, then we actually subtract. And the reason why these are important because logarithms come from the inverses of exponents. Logarithms are from the inverses. So we have these properties. The first property is called the product property, where if we have the log of a base, base b, and then we have that of m times n, we have that of a product. You can actually take that and separate the m and the n to separate logarithms with addition. If it's multiplication, when we separate it, it becomes addition. Just like up here, if we are multiplying, then we add the exponents. It's the same rules. So if we're multiplying what's in this spot, then we separate the logarithms with addition. Do you notice there it goes from 1 log to 2 separate logs?
Why would we want 2 logs? That's double the work. No.
Not if you can manipulate equations and make it easier for yourself in the long run. Is that what you're saying?
No, I was thinking it, but split up the two, so you can cancel certain things, make this
Yeah.
like something kind of one.
Yeah, because of that kind of thing, yes. All right, so then the next rule is if we have the log base b, it's called a quotient. If we have the log base b of m divided by n, then we can separate that to 2 separate logarithms with subtraction. Because division means we subtract the exponent. It's the same thing. Division becomes subtraction. And then power, when we have an exponent, becomes multiplication. We take that exponent and we move it to the front. And we multiply it by the logarithm. So power becomes multiplication. So let's manipulate these equations so we could, or these expressions so we could find answers when the only information we know is we just happen to know that log base 2 of 3 is approximately 1.585 and log base 2 of 7 is approximately 2.807. How can we find log base 2 of 3/7? So we're going to do log base 2 of 3 subtract log base 2 of 7. So I can separate it using subtraction, using my 3 and my 7. Notice the one that comes first is the one that's on the top of the division and the numerator. Then log base 2 of 3 is in the directions. It says it has a value of 1.585. And log base 2 of 7 is 2.807. So I can just type those in my calculator. Or do it by hand because it is just subtracting numbers, but I'm going to speed it up and type it in my calculator.